All right, kids, this is the intro to the copper Roman numeral 2 sulfate pentahydrate lab. Sometimes we just call it the pentahydrate lab. Sometimes we call it the blue stuff lab because the stuff is blue. CuSO4.5H12. Let's talk about this formula before we go any further, because this is a weird formula. We've not seen a formula like this before. The black part, CuSO4, copper is a +2 ion. Sulfate is a -2 ion, polyatomic, goes together 1-to-1 ratio. And then there's that weird dot that looks like multiplication, but it's not. That dot just means, in this case, loosely bonded. And loosely bonded to this copper sulfate, copper Roman numeral 2 sulfate ionic compound are 5 molecules of water. Now, as it turns out, some compounds are hydrophilic. That means they're water-like. They like water. Like a swimmer is hydrophilic. And then hydrophobic, they don't like water, right? If you have rabies, you'll become hydrophobic. Dogs that have rabies don't want to go in the water. That's one of the symptoms. But dogs don't get rabies too much around here. But the word hydrophilic means attracted to water. Now, different ionic compounds, some of them are attracted to water. It depends on their shape and size. They hold a certain amount of water. This stuff holds 5 water molecules, so it's called a pentahydrate. Other things are dihydrates or monohydrates or heptahydrates. There's a whole bunch of different hydrates. This one happens to be 5. So the compound itself is blue. It's a powder. And this is a weird thing. There's a little kind of cartoon I drew underneath it. It's a CuSO4 unit, and 5 water molecules just kind of glom onto it. Now, there's no real diagram to show this, but it has 5 water molecules that glom onto it. So the formula has 1 copper, 1 sulfur, 4 oxygens, and 5 water molecules. And when we do the molar mass of this, which we're going to show you in a little bit, we're going to do the water as a chunk. Even though there's hydrogens and oxygens, the water are particles called molecules, and when they get heated up, the water molecules go away and they stay H2O. So we're going to do the water as a chunk. We're going to do copper, sulfur, oxygen, and water. Now, on the next slide, this is the start. We're going to put a bunch of this blue powder into a cup. And in the slideshow, there's some really nice pictures of it. So imagine we got a whole bunch in a little evaporating dish. We put 3 grams of this. We got millions and billions, probably trillions of compound formula units. Each one has 5 waters associated with it. And then we're going to heat it up. Now, when you heat it up, you start shaking it, and all of a sudden the water shakes free because it's a loosely bonded. So this stuff is called a hydrated ionic compound. And by heating it, look what happens. All the water goes out, and we're left with just CuSO4 not hydrated. Actually, now it's called dehydrated, right? We started out, it was hydrated, and you get dehydrated. Now, in your life, if you're exercising, you drink some water, you got water in your body, you're hydrated. If you exercise too much and you sweat too much and the sweat evaporates, you become dehydrated. And what do you do when you become dehydrated? Well, you drink more water and you rehydrate yourself. We're going to do the same stuff in lab. We're going to take 3 grams of this stuff, and out of that 3 grams, some of those grams are just water. Some of those grams are just copper, some of them are just sulfur, and some of them are just oxygen. And when we heat it, the water evaporates, but the CuSO4, it can't evaporate. So out of the 3 grams we start with, some of it's going away. Now, if we figure out the molar mass to this stuff, here's how we would do that. We write the formula, and there's 1 copper in the formula, and copper has a molar mass of 64 grams per mole. There's 1 sulfur in this formula. Sulfur is 32 grams per mole. There's 4 oxygens. Each oxygen is 16 grams. And then we're going to do the 5 waters together. Now, how did I know it was 18? Well, I know a lot of things because I remember them, but you'll remember them because this is what you got to do on the side. The molar mass for water on the side. In water, there's 2 hydrogens. Each one is 1 gram. And then there's 5 oxygens. I'm sorry. There's 5 waters altogether. There's 1 oxygen, H2O. 1 oxygen is 16 grams. And you sum it up, water is 18 grams a mole. Now we got 5 of them, right? We got 5 waters, each is 18. So we're going to add this up and get the molar mass. Now out of this total molar mass, part of that mass is copper, 64 grams divided by the total. Part of that mass is sulfur, 32 grams divided by the total. Part of that grams is oxygen. It's going to be 64. 4 times 16, 64 again. 64 divided by the total. And the water, 5 times 18 is 90. 90 divided by the total. So a portion of the total, a percent composition by mass, is going to be water. So here's the plan. We're going to get 3 grams of it, and we're going to heat it. And while it's heating and the water's evaporating, it takes about 15 minutes, we're going to do the molar mass. And then on the other side, the other half of the page, we're going to figure out the percent composition by mass. Now this stuff is a certain percent by mass water. And we're going to figure out the percent. I know it, but you're going to have to figure it out. While it's evaporating away, you're going to figure it out. And then we're going to weigh it again. And then we have to heat it again, because when you heat it and the water comes out, you're never really sure if all the water's out. So you weigh it, you say, oh, let me write that number down. Then you heat it again. Now, if all the water is out, when you heat it, nothing's happening. You're just making it hot again. And when you weigh it again, it weighs the same. But if in fact the mass goes down a little, that means the first time not all the water was out, and hopefully the second heating will get the rest of the water out. But after 2 heatings, you're done. And you will be able to measure how much of the 3 grams is gone. Because you know you started with 3 and you know how much you got left. You can measure the mass of the missing water. Now this lab, let me see what we got on this next slide. The total molar mass of the blue compound is parts. I already told you about that. Now, this lab is to teach you about the percent composition by mass that water is in this compound. We're going to calculate it on paper. That's the actual value. It is a certain percent by mass water. Then we're going to measure it in lab. And we're going to measure what percent of it actually came out. And then we're going to compare what we know is the truth with what we measured. And we're hoping it's going to be pretty close. Now, honestly, you're not doing it. I did it. I took pictures of it. I took pictures of it when it was blue. I took pictures of it when it changed color, when I evaporated all the water. And I showed you the numbers. We can figure out the mass of the missing water by subtraction. And then we can do the percent of mass that's missing. The percent that's missing divided by the whole 3 grams. And we can compare before and after. Now, this percent composition by mass, a part of the whole makes up a percent of the mass. Just like the sugar makes up a part of the gum, it makes up a big part. Or if you have a mixed fruit salad or a fruit tart, parts bananas divided by the whole mass. The part divided by the whole is called percent composition by mass. You're going to have a good time. This is a fun lab. Unfortunately, you're not doing it, but there's a good slideshow. You got all the numbers. It's going to be easy. Make sure, I hate to say it, here's the picture, right? I saw photographs of this in the slideshow, set it all up beautiful for you. And unfortunately, I got to say that word again, but I'm going to turn to the page before I say it. You got to fill in the data table, you got to do all this work, and look, the rubric, right? You got to have a cover page, title page with a short intro paragraph, couple sentences. That's what 2 points. You got 15 questions and then 8 points conclusion. It tells you what to write about. Tell me, what did you measure exactly? What did you measure? What you calculate, that's different than what you measured, right? What is your percent error? And why did you get that percent error? And what can you conclude? Something sensible, like percent composition by mass is always equal to the mass of the part divided by the mass of the whole times 100%. It works for a compound like this, copper, Roman numeral 2 sulfate pentahydrate. It could be the same percent composition by mass for just water. What percent of water is hydrogen? What percent of water is oxygen? It works for a fruit tart. It works for everything. Part divided by the whole times 100%. That gives you the percent composition by mass. I love my job. I hope you guys are having fun. See ya. Watch the slideshow. I don't know how to turn this thing off. Here we go. End.